as we move on to 11-5, you're probably going to like 11-5 a lot more than you liked any of the others. The reason being is we are going to see today that the fractions or the denominators, we're going to cancel them, okay? So in your first blank it says, you'll like today more. We're going to cancel out the fractions. All right. Now, why today are we allowed to cancel out the fractions? Today we're going to cancel out the fractions because there is an equal sign. All right? And that's when you're allowed to cancel them out. Let's try to attack this. Ready? Problem 1. What is the solution of 5 over 12 minus 1 over 2x equals 3x? Check the solution. So the first thing I'm going to do is I'm going to figure out what my common denominator is. Are you ready? Well, the biggest number I see that they all go into is a 12. So I know that 12 is part of my common denominator. Now look at the variables. They each have, or at least have, an x. So my common denominator is 12. What I'm going to do now is I'm going to rewrite my problem so I have a little more room. And you're going to multiply through by a 12x. Now watch what happens here. To distribute through here, the 12 would cancel and you would need an x. To distribute here, the 2 and the x would cancel and you would be left with a 6 because 12x divided by 2x is a 6. To distribute through here, the 3 and the x would cancel and you would need a 4 because 12x divided by 3x is a 4. Now let's write what we have left. That's 5x minus 1 times 6, which is 6, equals 1 times 4, which is 4. Add 6, you get 10. Divide by 5, you get 2. Now what you need to do is you need to go back and check this in, make sure that it works. That would be 5 over 12 minus 1 over 4 if you plugged it in, and that would equal 1 over 4. Or excuse me, 1 over 6. That is a correct statement if you plug 2 back in, so we give it a check mark. Moving on. Get your common denominator in part A. Your common denominator in got it part A would be a coefficient of 3 and a variable of x. So I'm going to distribute part A. I'm going to distribute a 3x in. This 3 would cancel and I would need an x. This x would cancel and I would need a 3. This x would cancel and I would need a 3. That would leave me with 1x plus 9 equals 6 when you multiply. That's x equals negative 3. You would plug both of those answers in and check them. Excuse me, you check the one answer, because there's only one answer. You would get a true solution, and so you say it checks in. Part B. I'm going to multiply through by my common denominator. This time my common denominator is, let's see, we have a 7 and a 3. So 7 times 3, I would need 21 because they both go into 21. And my variables, the largest one I see is an x. So we go through and we multiply. And we distribute in a 21x. 7x would cancel and I would need a 3. 3 would cancel and I would need a 7x. 3x would cancel and I would just need a 7. So you got to be careful to figure out what it would be when you divide it out, okay? So this one would need a 3. This one needs a 7x. This one only needs a 7. 3 times 4 is 12, plus 7x, which is, because it was 7x times 1, equals 7 times 7, which is 49. 7x equals 37. X equals 37 over 7. You should really get a calculator, check it back in. It is a true statement. It's nice, huh, when they cancel out. Then all you have is a regular algebra problem. Problem 2. It's a little better, at least in my opinion, I think. Let's check it out and see if that's true or not, okay? What we're going to do is we got to get our common denominator. You ready? Your common denominator is made up of all the factors of the denominator that don't repeat. So we do 1 over 1. So I know my common denominator I need, let's see, the biggest coefficient I see is a 1, so it's not really important. And the biggest variable for the least common multiple is an x squared. So my common denominator is an x squared. So now I need to distribute an x squared. This 1 would cancel, and I need an x squared. This x would cancel, and I would just need an x. This x squared would cancel, and I would need nothing but a 1, or a check mark, whichever way you want to see it. 1 times x squared is x squared, minus 1 times x is 1x, or just x, equals 12. Now you have to remember here to think about chapter 8. Actually, I think we did do this in chapter 8. Whenever you see x squared, you set your equation equal to 0. So let's say when there's an x squared, set your equation equal to 0. So we're going to take 12 over and get x squared minus 12x minus 12 minus, x squared minus x minus 12 equals 0. You'll factor it out. X minus 4, x plus 3. And now you might wonder, how is that going to help me get my answer? Remember guys, you just set each one equal to 0 then and solve. So in the first part, x equals a positive 4, and in the second part, x equals a negative 3. Plug both of those answers back in to check them. And if you'd like to see, here I can cheat, see the book? If you'd plug them in, if you're struggling with what I mean by plugging them in, take a look how they did this. You just plug in 4, and you end up with an answer of 3/4. You plug in negative 3, don't forget to use parentheses, and you get 4/3 equals 4/3. So both of them is correct. Both of them are correct. Let's try the got it. Alright, same thing, let's get our common denominator. 6 is technically over 1, so my common denominator in this case is a 1y squared, or just y squared. I need to distribute it in and see what's missing. This y would cancel, and I would need an extra y. This y square goes away, so I'm done. This cancels, and I need still a y squared, Alright, multiply. That's 5y equals 6 minus 6y squared. Now what we need to do is, you see how we have a y squared? I'm going to take it to the left and the 6 to the left, because anytime you have a squared, you set it equal to 0. So a positive 6y squared and a positive 5y. And then when you move this 6 over, a minus 6 equals 0. So I put them in order and I set it equal to 0. Now I need to factor to solve. In order to factor this, let's see, go ahead, try to factor it, and then check your answer with mine. Pause the video if you need to, because I'm going to give you the answer. It's 3y minus 2. And 2y plus 3. If you don't understand that, here you go. It's because the insides give me negative 4, the outsides give me a positive 9 and negative 4 makes a positive 5. Now you need to set each of these equal to 0 and solve. For the first one, you should get y equals 2 over 3 when you add 2 and divide by 3. Here you should get y equals negative 3 over 2 when you subtract 3 and divide by 2. You should plug both answers in, and you will realize that both answers are correct. Part B. In part B, I'm going to give myself my parentheses. These are each over 1. And I can see that the only denominator I have is d plus 3. So that's my common denominator. I distribute it in, and this one gets a d plus 3. This one gets a d plus 3. And this one's done. The d plus 3 will go away. So that leaves me with d times d plus 3 plus 6 times d plus 3 equals d plus 11. I'm also hoping that you guys are noticing how helpful, as much of a pain as it was in 11-4, how helpful 11-4 is to be able to understand 11-5. So we get d squared plus 3d plus 6d plus 18 equals d plus 11. Now you see how you have a d squared? We're going to set everything equal to 0. So I'm going to move my d over and combine like terms. And my 11. You ready? So d squared, so 3 and 6 makes 9, minus 1 makes 8d, 18 minus 11 is 7. Now I move on to factoring after you set it equal to 0. And I get d plus 1 and d plus 8. And then I finish by setting each one equal to 0 and solving. After you solve each one, you should get d equals negative 1 and d equals negative 8. You can plug them both in, excuse me, not 8, 7. I apologize, that parenthesis should be d plus 7. And this answer should be d negative 7. I apologize. You can plug in negative 1 and negative 7. You will notice that it would give us true statements up here at the top. You guys really should take some time and pause the video and learn how to check things if you don't, okay? Or ask me tomorrow, and I'd be more than happy to show you. Alright, we're going to do a work problem on the next page. It's actually a pretty neat problem, something that you might find pretty beneficial when it comes to doing work with two people.